Good morning, students. For those of you that weren't here yesterday, just a reminder that I did post the yesterday's video lesson online. I opened a new YouTube account and I sent you the link via your email, but it's also on Students Achieve. So we were looking at arithmetic sequences, a review from grade 10, and we're going to continue that lesson today. But we're going to look at the series part. And a series is the sum of all the terms in a sequence. So before I begin, though, I want to talk about this fella, Carl Friedrich Gauss, born in 1777. You know, Carl is listed in history books as the Prince of Mathematics. He was a child prodigy. Now, just to give you a little bit of history about Carl, he didn't come from a very wealthy family. His father was a merchant of some sort. He was a shop owner. And the story goes like this, that, I remember back in those days, um, our the merchants would be selling their wares and they'd have to keep their own books. We had no calculators when they were dealing with this, like writing. They had no pencils and erasers. They were dealing with inks and quills. All right, and working at night with candlelight. And so he's working away, and you can just imagine this very tired man. And his little boy, who's 3, is like, Daddy, Daddy. And he's like, Go, just leave me alone, Carl. Let me get to work. And so the little boy keeps nagging him. He goes, Shoo, shoo, go see your mom. He comes and he goes, Daddy, though, you got the wrong answer. And he goes, I know, it's not balancing. That's what Dad said. And and Carl goes, But Daddy, Daddy, you have the wrong answer. And he's like, Carl, just leave. And he goes, No, Daddy. And the answer is, and was able to tell him what the answer was. And so his father looks at him and looks at his sheet again. And he goes, That's the answer I should have. He's trying to balance his accounts. And his 3-year-old had the right answer. Were any of you like that when you were 3? I know I wasn't. All right, so automatically they're kind of cluing in their son is gifted. Right? He is very bright in math. Numbers come easy to him. So they did get money together and they were able to send him to school. And the story that we're picking up with, and you'll see it in your textbook, it talks about him being about 9. 9's kind of the age I picture this story happening because it would be grade 4. And although he could have even have been younger, but I am just picturing those grade 4 boys, the ones that like to tie your braids in hair in a knot or something along that line, fooling around, causing some mischief. And keep in mind that those times they're studying, they probably have a slate, which is like I have that slate, the computerized one, it'd be about that size, but it's like blackboard with a little bit of chalk. Okay, no calculators, no calculators. And the And so we have 9-year-old boys kind of acting up. And so the story goes like this, that the teacher was getting a little frustrated. It's probably one-room school or one-room classroom and trying to get other things going on and wanted to keep these boys busy. And he gives them a task and he says, okay, guys, all right, enough of this. Let's get to work. You just go and add up the numbers 1 to 100. The first one done, come see me. So he thinks, here's a breather. It's going to give me a little bit of a chance to get some work done. It didn't take long at all before Carl was up at his desk. And he goes, Carl, I said, you come see me when you're done, but I have the answer. Oh, I don't think you have the answer that fast. You go tell me when you're done. I'm done, sir. He goes, well, if you're done, what do you think the answer is? 5,050. And the teacher realizes, yep, I got a smart cookie on my hands. Well, why am I telling you these stories? Not because I just think Carl Friedrich Gauss is the best mathematician in the world, but because the principles that he actually did when he was 9 are principles that we use now. We did them in grade 10. We're using them in grade 12. So let's just take a look at how did Carl come up with this answer? Because he didn't add them up. He didn't take 1, add 2, add 3, add 4. Okay, add them up. Here's my remainder, next column. He was thinking outside of the box. This is kind of what he had done. And we know this because, again, it says I did do a modification here, and then I forgot to take out a number, so we'll change that. 1 to 100. Just to see what what he had done. And he said, well, here's the sum of the numbers. And we know that this was his strategy because he was the one who was able to come up with the formulas for us. And it's explained how we look at things. So he said, well, if I sum up these numbers 1 to 100, I'm going to have something like this. 1, add 2, add 3, add 4, and so on, add 97, 98, 99, add 100. But you know what? That's the same thing as if I do them in reverse order. Right? I'm still going to get the same sum. Now what happens here? Let's add these together. Let's add down. S plus S, 2S. 1 at 100, 101. Oops. You're going to notice I have an error here. These I'll say 1001, so I didn't modify. Let me just fix that and we'll just continue in a second. Okay, let's see if I made those changes appropriately. All right, so 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. What do you think's happening? Yeah, these are all going to add vertically down to give me 101. Okay, so where do we go from there? All right, so I have two S's, two sums. Now, how many numbers are there? 101 plus 101 plus 101, how many numbers? Yeah, there's 100 of these. 100 times 101. Then what do we do? Oh, well, let's solve for the sum. Two sums give me 100 times 101. One sum is going to give me, I'll just show the work, that divided by 2. So that's that. That is 50 times 101. That is 5,050. Way less time to do that quick multiplication than it is to add up all those integers. Wow, how cool is that? Well, what's happening here? What's our formula? Well, let's look. What is the 100? The 100 that we have here is a number of terms. All right, so let's look at this. Sum, number of terms. I have this divide by 2 thing going on. How do I get 101? Well, it was basically looking at the number of my first term and my last term. Right? If I look at this, my first term and my last term. And there is the sum of an arithmetic sequence. And that's what Carl Friedrich Gauss had developed at the age of 9. Okay, let's look at the formulas. So we have this one, right, that we just looked at. Typically, it's written instead of all over 2, we just put that fraction in front. But we know that that doesn't really matter. But we don't often have that last term. See this Tn? That's, if there's something missing from this particular formula, it's probably the Tn. But remember from yesterday, Tn is equal to A plus n minus 1 times d. All right, so we can do a substitution, just like some of you do in volleyball or basketball or soccer, right? Let's substitute another person in. It means it has the same value, they're playing the same position, everything. So I'm going to put in for Tn, A plus n minus 1d, and then simplify it. And when I simplify it, this is what I get. And really what it's doing, it's taking the formula for Tn is equal to A plus n minus 1d, putting it right into that first formula. Right, so now the Tn value isn't necessary. So these formulas haven't changed since grade 10. They're the same ones. They're the same ones since the 1800s. All right, we're going to be dealing with these formulas. So after yesterday, you should know that A is the first term in the sequence, D is the common difference in the sequence, Tn is the term for a specific number in the term, like the nth term, if I want the fifth term, the value of the fifth term, and is its placement. All right, let's look at an example. Find the sum of the terms in this sequence. Okay. We're not even giving you baby steps. We're going to hit to one of the harder questions from grade 10. All right, but remember that was grade 10, so we can handle that in grade 12. Let's list the information we know. All right, so always start with that. A, first term, negative 29. D, that's my common difference. And these numbers are going up. They're growing. They're getting bigger every time. So D is 5. Now, look at this. We have those ellipses, which means and so on, but we also have 126. And the 126 says, okay, here, we know the last term. And I want to find the sum. Uh-oh. Something is missing. There's something in both formulas that we need to have in order to find the sum. I need to know how many terms are in this sequence. And there are not 4. The answer is not 4. There are 3 to tell me what the sequence is like. And then there's a whole bunch of others, and then I get to 126. Question is, how many are there altogether? Well, we're going to go back to what we do know. We do know from our arithmetic sequence this. I know Tn, I know A, I know D. I can find N. If you have 4 unknowns or 4 variables listed in a formula, and you know 3 of them, you can always find the 4th. So let's put the information in. And I wish you were here, just so that if I make a mistake on the board, you could tell me, but you're not. So let's see if I can do a better job than I did last night when I was recording. All right, distribute through. 126 is equal to negative 29 plus 5n minus 5. Okay, and doing some math here, I get 160 is equal to 5n. N is equal to 30, 15, and that's a 1, 2. Right, N is equal to 32. All right, now I know that there are 32 terms in the sequence, and now I can use either one of these 2 formulas. Now the one that most people like to use the most is going to be this one. All right, so now let's put it in. Just writing in the information we know. We know A is negative 29, Tn is 126, N is 32. So that gives me 16, and this gives me 97. 16 times 97, and I'm not doing the mental math, I'm checking to see what my actual work is, 1,552. So if I was to add up this sequence of numbers starting at negative 29 and going to 126 following this sequence, I'd have a sum of 1,552. Okay? This one's on the harder ones. We're just using a formula. My harder ones from grade 10. But we're going to pump this up, make it grade 12. And we want to look at this, and you might say, oh, it's starting to look a little Greek to me. And it should. That's called a sigma. Right? It's called sigma notation. And sigma is actually the S comparable to the English S in the Greek alphabet. And this is a capital sigma. And when we're dealing with that, this is saying this is a summation. Anytime I see that symbol, right, and I'm hoping you know which symbol I'm talking about, this one right here. When you see that symbol, it's not an E, it's sigma. You have to know what that is. That is indicating, hey, it's a sum. We need to sum it up. Okay? Now, there's some parts to this that we need to have a look at. Now, this is an arithmetic sequence. We have a couple of things we want to look at. This is a lower limit. That doesn't look like I'm writing anything. Lower. Lower limit. This is the upper limit. The n equals 1 is telling me I'm going to start this thing when n is 1. It's kind of like a computer loop. do while or for next type of loop. So you're going to start, you're going to put n is 1 into this sequence. Okay, find the number, then you're going to go to 2, n is 2, and then n is 3, n is 4, n is 5, and then you stop. And then you would add it up. Okay, let's look at some other things that we know. If we want to translate this into an arithmetic series type of a problem, we need to know that the number in front of the n is my common difference. How cool is that? I can figure out how many terms there are by looking at my lower limit to my upper limit. I can tell that this number in front of the n, that's going to give me the common difference that I have. Okay, so these pieces of information are going to help. This is the general term. This entire thing is equal to Tn. If that's equal to Tn, I can find the last term or a specific term. So all of that's interconnected all within that notation that we have. The textbook is going to ask you to expand it out. Now, I will not do that, as I just think that's a whole lot of needless writing, but I want to do it once with you to show you what they mean by that. And I'll get you to do it once for homework. One of the questions, you can just do it once. So let's look at how we would go about doing this problem. I'm going to erase all the red ink. And how we're going to work with this is that we're going to say, okay, for my first term, the value I have here is 1. So n is 1. So this would be 3 times 1 minus 1. That's my first term. Okay? Okay, my second term. I no longer have n is 1. It has to increase a number, so it goes to 2. So this would be 3 times 2 minus 1. And then I'm going to go to 3. So this is 3 times 3 minus 1. And then it's going to go to 4. And I get 3 times 4 minus 1. And then it looks like I've run out of room. So we do a little smartboard thing here. Move it over. Group it all together. Decrease the size a little. All in the instance of making sure that this fits on the smartboard page. There we go. How do I know when to stop? Well, it says just go from 1 until 5. All right, now let's continue. 3 times 1, subtract 1. 3 subtract 1, 2. Add. 6 subtract 1, 5. Add 9 subtract 1, 8. Add 12 subtract 1, 11. Add 15 subtract 1, 14. 2, add 5, add 8, add 11, add 14. I've got 15, I've got another 25, 15, 25. You see, I'm not good with mental math. I'm losing it. 30, 40. All right, so sum of 40. All right, so this thing says, oh, it adds up to 40. I don't like, just to me, it's almost like brute force. I just having to put all those numbers up and then adding all the numbers up. The more I do that, and I'm not doing it algorithmically based, then the numbers don't maybe have as much meaning, or I'm more likely to punch the wrong number into a calculator, or some of you are like, okay, going to your calculator automatically, you have more numbers to input. There's more room for mistakes. This is a really good concept, though, in computers when we're looking at loops. Okay? So I know I liken it a lot to that. And some of you are saying, well, we don't understand what you're talking about. But for those that do, those that would do some programming, they might see that connection with a loop. But I'm going to use a black pen now, and we're going to say, okay, can I do this using my sum formula? Well, D is 3. How do I know that? From this number in front of the n. How do I know that? Look at this. Look, it came out. Right? I'm pointing and you can't see here. Sorry, I forget. Right? 2 to 5 to 8, those are each going up by 3. If I want to find A, that first term, I'm going to take this n is 1 and I'm going to put it in. And I get 3 times 1 minus 1. That gives me 2. So A is 2. N, how many numbers are there? 1 through 5. 1, 2, 3, 4, 5. Now I have a saying. Add it up, let sum. Count on your fingers and even your thumb. Because sometimes we're going to see this limit change, and if it confuses you, count them out and see how many numbers there are. Okay? Now I have A, I have N, I have D. I have enough information to do the formula, the second one. Or I can even do the Tn. You know what Tn is. Tn is 3 times 5 minus 1, which is 14 if you want to do that. We pick up one of those two formulas. All right. I'll do the longer one. And sorry, I forgot. N was 5 numbers. Now, no, when you're doing mental math, this is just one of these things. I'm not taking the 5 and dividing it by 2 to get the 2.5. I'm going to leave there because that means I've got a decimal to deal with. But hey, 2 goes into 16 easier. 8 times and 5 times 8 is 40. I can actually, oh, I'm probably the weird one. I could actually do this work almost faster than I can adding up digits. Okay, so I deal with smaller numbers or least number of numbers possible when I'm doing the math. So this is just an example of how we use the sigma notation, and I just think we need some practice with it. So here's one for you to do. I'll just ask the substitute right now just to pause it so that you can do the problem. All I'm asking you to do is find the sum, whichever way you want to do. But we are going to get to a point that I am wanting you to use the formula. But you're saying, well, you know, there's only 9 numbers. I can add up 9 numbers. But what if I said I wanted you to add up the numbers from 1 to 100? Or using this sequence, the first 100 terms. Hey, there's no power in that. So use the formula. There's power in it. So I'll ask substitute to pause, and then I'll come back with the solution. Okay, I didn't do this one out, so I have the calculator in my hand. I'm going to work it out with you. I know that my common difference is -1. It's going down by 1. I know that because of this number right there. And you're like, oh, that's not a number. This is callback. That's a negative sign. Yeah, but what number is understood? A 1 is understood, so that's a -1. So these numbers are going down by -1. All right, K. So hey, I switched it up on you. I hope I didn't trick you. I put a K there instead of an N. Could have a J, could have an I. Interesting fact is that you tend to see triads of letters. We know that A, B, C, X, Y, Z, L, M, N. Another one we tend to use is JKL, IJKL, right? An iterated loop, and we've heard that, it's like sometimes the I. So you'll see those types of letters in down here. N for number, but it's grouped with letters closer to it. Just interesting fact. All right, so A says, okay, we're going to put in a 1 wherever there's a K. So it gives me 0. All right, so A is 0. And how many numbers are there? Well, there's 9 numbers. If I want to, I can find Tn. There's 9 numbers. Tn is -8. I don't know if any of you tried that to use the formula. And here's what we get for an answer. So using my sum formula, because what I want to know is what is this sum? That's really what's being asked of me. Find the sum. Oops, this cord just got hooked. There we go. All right, so n over 2 on the first and last terms. Oh, first term is 0. Last term is -8. Oh, this makes this easy. If I just add them up, I get the answer of -36. Hopefully get the same answer, and hopefully I didn't make a mistake. But you'll let me know tomorrow, or I guess next week if I did. All right, let's look at another example. Now, in this example, I'm saying, okay, here's the sequence. I want you to write the sigma notation that goes with it. Now, here's where we're going to start to trip things up later on, so just be aware that this is not automatic. It will tell you what limit we need. So how do we go about doing this problem? Well, like we always do, let's start with the information we know. Okay, we know, okay, the first term. Now I'm using A because we're used to that. What else we can denote this as term number 1, right? Term number 1 is A. So that's 3. Our common difference is 5. It's going up by 5. How many terms are there? Well, there's 6 terms. I know the last term is 28. That's not really going to help me, but I have enough information to set up my sigma notation. All right, so here's my sigma notation. I know that, let's say the n is going to go from 1 to 6. 1, 2, 3, 4, 5, 6 numbers. And you can't see me, but I just counted on my fingers. So the question is, what goes in here? If you remember back, actually, you may not, but I'll go. Oh, I erased it too, didn't I? Yeah, I did. Okay, sorry. I said that that's going to be your Tn. All right, so in here, it's your general term, which we looked at yesterday. So let's find our general term. I know A. A is 3. I don't want an n because I'm looking for the general term. I'm looking for the explicit formula. Maybe I should even write that in. This is the explicit formula. All right, that's what's going in here. All right, and our common difference is 5. So Tn is going to give me 3 plus 5n minus 5. Tn is equal to -2 plus 5n, or 5n minus 2, or yeah, it doesn't really matter. So this value goes here. All right, so I put in -2 plus 5n. Now, let's look at this question just because we're going to be using it again. And this is a sequence of 6 numbers. We add this sequence up, and we're like, okay, well, I wonder what it adds to. As I'm going to be doing some work, I'd like to make sure I know what it adds up to. So if you put that in your calculator even as it is, you should get an answer of 93. And that's not going to change even if I change this limit around, because it's still going to be those 6 numbers I'm adding up. Okay? We're going to play around with it. But what you need to know is, how am I getting what I have here in the box? That's the explicit formula. I have my beginning, where I'm starting from, my starting point's called my lower limit. How many numbers? Now, it's not always going to be a 1 through 6. If my lower limit changes, I still need to account for 6 numbers. All right, let's look at some more examples. Let's switch this up. And like I talked about, it's not starting at 1, I'm starting at 3. You're like, why? Well, I'm like, okay, we don't have to. We're just going to jump ahead and just take that section of the sequence. And what would that add up to? I don't want the first and the second term. I want to add up the third term to the ninth term. I really don't care. Let's give you maybe an example. Okay, let's say that it is salary of a teacher, and we don't want their first 2 years. The first 2 years, there are probationary years, and we want off of that. How much money do they make? All right, and how many years? Well, they've been teaching for 9 years, but I really want to know how many years we have that we're looking at is their third year to their ninth year. How many years is that? It's not 6. Let's count on your fingers and even your thumb. Add it up. Let's sum. All right. So we got 3. I'm counting my fingers. You want to do it with me? Starting at 3, 4, 5, 6, 7, 8, 9. I got 7 years. So N is 7. Okay. So we're looking at 7 years. And why? Let's go back to that teacher salary. You're saying, well, there are 2 first years probationary. We know that their salary was lower. We just want to know, well, what was the sum of their salary? How much money have they made since they've been a tenured teacher? So in the last 7 years, how much money have they made? That might be a reason why we're doing the sum question. All right. I want to know my first number from my formula is really what I'm going to look at. So how do I calculate the A? Well, I'm starting when it's 3. So in this case, wherever there's a K, I'm going to be putting in 3. And that says, okay, for this, using the formula, I'm going to start my sum at the 1. All right, so that first number in that sequence is the 1. I know N and I know D. D is 2. Okay, so let's use our formula. Remember, we're wanting to know what the sum of this thing is. So Sn is equal to n over 2, 2a plus n minus 1d. Of course, you may be saying, well, I could have found Tn and then had done it there, and I could have. I didn't, but I could have. So I got the sum of this to be 49. So if I was to put in 3 in for the k, and then I was to put in 4 in for the k, and a 5 in for the k, and a 6 in for the k, and a 7, and then an 8, and then a 9, I'd get a sum of 49 when I'd add those numbers up. Okay, let's move on to another one. Interesting. We haven't done anything with a negative number before. I thought in our sequence it's like we just start with the first one. Now you're saying you want to start with a negative 2 1? Like, where's that? I thought like the first number is the first number. Well, let's say we can see the pattern. You can extend the pattern to the left, right? Extrapolating the information. Not just that sequence that's given, but okay, oh, well, if it's going up by that, you think, okay, well, maybe it went down by that amount at the beginning too. So we're kind of doing some extrapolating. So I'm just going to give you a moment to see if you can figure it out. I'll ask the substitute just to pause here. See if you can figure it out. It's very similar to the last question, except in this case, we're starting at -2. Here's the trick. Here's the warning. How many numbers are there? All right, give it a try. Okay. How many numbers are there altogether? -2, -1, 0, 1, 2, 3, 4, 5. Add it up, let's sum. Count your fingers and even your thumb. All right, I get 8. Now some of you might already come up with a formula for this. All right, whatever works as long as you're getting the right number. Okay, I'm not going to tell you what it is. A couple of the ones in my class last year said, oh, I just do this and this works every time. And I was like, oh, I like that. I'm not going to tell you that formula. Maybe someone else can find that pattern if you can't find that pattern. But there's 8 numbers there, right? The value of that first number, 2 times a negative 2 minus a 5, negative 9. Negative 4 subtract 5. D is 2. Okay, so I got negative 16 if I was to add them all up. Okay. Here's another example. Given this sequence, write the corresponding sigma notation with a lower limit of 5. Okay, remember, we have just done this question previous. I lost track of which number it was. We've added up these numbers and they give me 93. And that's not going to change. It still has to be 93. But it is a little tricky, so I figured, okay, I'm going to help you with this. All right, so I'll do this one, and there's another one for you to try. Okay. So, oh, sorry, did I say, I can't remember what I said. Lower limit of 5. Okay, I'm looking at my notes, and I had a sample one here, the lower limit of 3. That's what confused me. Okay, so when I'm doing out my sigma notation, starting here. So guess what that means? This is not my first term per se for this sequence. This is term number 5. Now it's the first term that I'm adding up, but it is the 5th term of the sequence. And because of this, I need to keep that in mind. All right, so term 5 is equal to 3. Okay, what other pieces of information do we know? We know D. D is 5. Okay, we know Tn, the last one, all right, but we don't necessarily need that. What we really want to find is the A that we're looking for. What is A? Remember, don't get first term and the A are usually synonymous. In this case, we're using A for the formula when we're looking at the sum. And it happens to be that that first number for that summation is the 5th term. So I found this kind of easy to do. I'm saying, okay, the 5th term is 3, and it goes up by 5. Well, you can extrapolate from that. What does it mean about the 4th term? Well, it's down 5. Okay, so it would be negative 2. And the 3rd term would have been negative 7. And the 2nd term would have been negative 12. And the 1st term would have been negative 17. Hey, it's not so hard. Except it gets more difficult if I said, well, let's just jump start it at the 25th term. Yeah, that's a little bit harder. So this is kind of a neat little trick, and I'll just move over to this side to try it. I know that my 5th term is 3. Let's treat this as the Tn. So I'm going to say 3. Let me write it down like this. What's Tn? Tn is equal to A plus n minus 1d. In this case, this is 3 for the for my 5th term. And my d is 5. A is 17. Well, why do we need that? Well, I remember what do I need in here is the explicit formula. That needs to be the explicit formula. So I need to use this to find my explicit formula. To find the explicit formula, it's your general term. It's the one that has all the n's in it. I'm just going to leave the n's in place. So a is negative 17. D is 5. So in this case, the negative, lost my pen, negative 22 plus 5n goes in there. Oh, we're missing a piece. We're missing our upper limit. Okay, how many numbers are there? There's 6. All right, so if I start at 5, what number do I go to? 5, 6, 7, 8, 9, 10. That gives me the 6 numbers. Confusing? Yeah, this one's a mind stretcher. You really got to feel comfortable going back and forth. And you're saying you're using the same variables and same formula, but not the same thing. It is confusing. It's more of a global understanding that we're going to have to work on. All right? How do I know that this works? I can't just use what I would have done before. I had a different limit. Put a 5 in, find your A, right? And you have your D. You know there are 6 numbers altogether because n is 6. I know that because there's 1, 2, 3, 4, 5, 6. And if that should equal 93. Because it's the same set of numbers. Okay. This has a lower limit of negative 2. Give this one a try. I ask the substitute deposit, and then I'll give you the answer. Okay, so I'm looking for the lower limit of 2. Let's look at information I have. Or sorry, of negative 2 is what it's saying. So t term negative 2 is 3. Yeah, that's kind of funny stuff. That's working backwards. Okay. I may want to think about it as, well, can I figure out if this is negative 2, this is negative 1, this is the 0 term, this would have to be the first term? Yeah, sure, you can figure it out like that. It's not that powerful to do, but it works. Or I gave you a strategy last time. This is the negative 2 term. Never dealt with that before, Mrs. Colbeck, but remember we got Tn is equal to A plus n minus 1d. Well, let's see what it gives me. I'm looking for A. What term number is this? One's negative 2. Never heard of the thing, but that's what it is. Negative 15. Bring it over the other side. We've got positive 15. Add 3 gives me 18. A is 18. All right, I know that D is equal to 5. All right. How many terms are there? Oh, there's 6. Lo and behold, same 6 that we just dealt with. We know the sum's 93. How do I write the sigma notation if I change this limit? Well, we need to now find the explicit formula. And I get 13 plus 5n. I think I'm ready to write the sigma notation. How many numbers? There's 6. I need to know what number does this go up to. Negative 2, negative 1, 0, 1, 2, 3. That gives me 6 numbers. This is the sigma notation that represents this sequence of numbers. When I add it up using the summation notation I have, I will get 93, which is the sum of those 6 numbers. I know this one's blowing your mind a little bit. That's okay. You're just going to have some practice. Okay, page 295, page 296. And I don't know which numbers. Oh, there's a Decimal and negative 17 and 18. They look nice, friendly. How about doing 21, 23, 25? To just get you used to it, and then one that has a different change in the lower limit. And yeah, we'll do a couple of these with different ones for lower limit. We will do 27, 29, 32. 27, 29, 32. If you have more time, which I don't think you will, but let's just make sure that you know you can always go on. And 35, 36 are typical questions that you have seen before. So those are not a stretch. Okay. Just for close off, just to remind you that your assignments that were due yesterday, I will have those marked for you for Monday. You're just going to have to come in and get them. And that you are expected to be here, and we'll be doing attendance in homeroom. So that's you with me Monday morning, and then uh, picking the spots to go to for career day. Okay, thank you very much. And I am around the school. If you need, if you're in need of me, you can get a message to me from the office. All right.